Okay, so a manufacturer makes ball bearings that are supposed to have a mean weight of 30 grams. But they're supposed to make them just right. A retailer, somebody who buys the ball bearings from the manufacturer, suspects that the mean weight is actually less. He's suspecting that the manufacturer is not making them right. The mean weight for a random sample of 16 balls. So he grabs a random sample, right? How do you determine truth? How do you find statistical evidence? Well, you grab a sample, right? You grab a sample of 16 ball bearings, and the mean weight for that sample, for that little group of 16 ball bearings, was 28.6. Huh? That is lower than 30. It is looking a little shady, maybe, with a standard deviation of 4.4. At the 0.05 significance level, test the claim that the sample comes from a population with a mean weight less than 30. What's the conclusion? All right. So looking back at the exam notes, let me go there. What's the first step? Write the claim. Don't skip that step. That's really helpful to you. Write the claim. I know everybody wants to skip that step and get on to the calculator, but you will do yourself a lot of good if you do not skip that step. It all comes from the claim. Every time students come to me and are confused about how to finish these problems, it's because they didn't write the claim clearly enough. So make sure you don't skip this step. So what's the claim? What are they saying? See it right here? The mean weight is actually less than 30. That's what's being claimed. The mean is less than 30. That's what the retailer suspects. That's what he's claiming. That's why he did a study, because he's suspecting that the manufacturer is not really doing what he's supposed to do and make these ball bearings have a mean or average weight of 30. He suspects it's less. So mu less than 30. Right? Mean is the U thing. It's not, this is not a P percentage one, is it? There's no percentages. This is a mean one, an average one. So we're saying the average weight of the ball bearings is less than 30. Right? Remember, the alligator mouth is open towards the bigger one. The 30 is bigger, the U, the average is less than 30. That's what's being claimed. All right. So what's our HO? What's our H1? What's HO always? What does it say? HO is always equals. And then either HO or H1 must be the same as the claim. All right, keep those in mind. That's every hypothesis test. So HO is equals always equals. And then the claim, that's why we had to do the claim, because one of these two has to match the claim. Well, it can't be HO because HO is equals. So therefore, the claim must be down here on H1. And then you write the evidence. Remember, tells you to do it right here on the notes, exam notes. It says, write weak evidence by HO and strong evidence by H1 always. No exceptions. So we go weak evidence. It'll take weak evidence to conclude HO. It'll take strong evidence to conclude H1. It's like a court of law. The HO is the assumption of innocence. You assume the person is innocent. Somebody accused, you assume they're innocent. If evidence is weak, you're going to keep that assumption and you'll let the person go. But if evidence is strong, then you'll convict, right? It takes strong evidence. Just same thing in a hypothesis test, exactly like a court of law. All right, on we go. What do we?
Is HO always going to be weak?
Yep, always. Yep. See, it's right here on the notes. Yep. Weak
Okay.
Next to HO. Always. Just like the court of law, you always assume innocent.
Okay.
And if evidence is weak, you always let them go. You don't, in some countries and in some times in the past, they would kind of assume guilty. Like if somebody was brought before a court, they would pretty much assume they're guilty unless they can prove their own innocence. Well, our justice system is not that way. We assume innocent unless strong evidence is guilty. That's exactly what we're doing in the hypothesis. We assume we stick with if there's weak evidence, we're going to stick with HO. We're assuming HO is true. HO is assumed to be true. So if the evidence is weak, we're going to stick with HO. If evidence is weak, innocence will be the verdict. HO will be the verdict. But if evidence is strong, then we'll go with H1, just like in a court of law. All right. So next step is we have to go to the calculator. What is the calculator? Here it is. Here's the calculator stuff. Do we have a P percentage? No, we have a mean, don't we? So is there no data given or data given? What do we have on this problem? Was there a listed data on this problem? I don't think so. There was no data. So we're right here, aren't we? We're on the mean with no data given. So that's going to be a t-test. We got to choose t-test and then stats. So that tells us what to do on the calculator. T-test and stats. Right? See, there's no list of data, is there? In other words, there's not some big table with with a bunch of numbers like let me show you one. Like number 2. See how that's a list of data there? So we don't have anything like that, do we? On this question. We have no list of data. All right, so no data. So it's a mean, no data. So we're going to go to t-test. So let me write that down here. So mean, no data. So we hit the stat button, go over to, what is it? Stat, go over to tests, go down to t-test, which is just number 2 right away. T-test, and hit enter. We good there? We choose t-test, and when you do, then you choose stats, you highlight the stats option and hit enter. And then you'll get your options. And so I'm getting U sub 0, X bar, S sub X, in, and then the U, whether they want greater or less, not equal. All right, so here we go. So U0, you know the U0 always comes from the H0, doesn't it? 30. That little sub 0 reminds you to go back to the number next to H0, 30. X bar, what's X bar on this one?
$16?
Well, whenever there's a bar
Wait.
over something, that means the average, right?
Okay.
28.6. The 16 is the number of ball bearings they sample.
Mm-hmm.
And the standard deviation, that's the 4.4. Yeah, so anything with a bar over it means average. So there's 2 ways we write average, the U or the X with a bar over it. So you know whenever you see X with a bar or the U, that means average. Let me write that for that's what the symbolism means. The X with the bar or the U, those are 2 different ways they say average or mean. So we have 2 different words, we have 2 different symbols. X bar or U. That's actually a Greek mu, it's a Greek M for the word mean. That's what it is, but anyway. So the X bar or the U means mean or average. So yeah, so the average, the mean is 28.6. All right, so, and then finally, we're supposed to just do, here we just do the same as H1. What's H1? Less than. So we choose the less than option and hit enter to calculate. So I'm going to do that too. 30. Put in the numbers now. Choose the less than option and calculate. All right. I'm getting some numbers. I love it when we get the numbers here at the end. I'm getting a p-value. Here's what came out for me. My p-value equals, make that a little bit better for you. My p-value equals 0.1112. It's really all we care about is the p-value and the alpha level. What is the alpha significance level? Does it say?
0.05.
Yeah, right there.
Okay.
That's, oh, sorry guys. Here it is, 0.05. So, right, everybody seeing that? We have the p-value and the alpha. The alpha is the significance level. So now we're supposed to compare those. We're supposed to say which one's bigger, which one's smaller.
The p-value is bigger.
Bigger, yeah. 0.11 is bigger than 5. Yeah, 0.11 is bigger than 0.05. So the p-value is bigger. The p-value is bigger. What does that mean? So remember our conclusions. Remember down here, the two options. So option 1, if the p-value is low, meaning if it's less. No, that's not us. Our p-value is greater. So we're down here to option 2. The p-value is greater. It's not low. What's the saying? When the p is not low, the null must not go away. This means when the p-value is not low, the null must not go away. That is, we fail to reject the null, and instead we keep HO, weak evidence. That's our conclusion. Let's go back up here. Okay, so we're going to say exactly what it just said. P is not low. So HO, kind of running out of room here. HO does not go away. Keep HO. Keep HO. Does that make sense? The P is not low. It's greater. It's greater. So it's not low. P is greater. It's big. It's not low. It's big. P is not low. So HO does not go. Does not go, right? If the null is, if the P is low, the null goes. If the P is not low, the null does not go away. Instead, we keep it. We keep the null. So our conclusion in the debate between the two attorneys, our conclusion is that we are going to keep this one. We're going to keep HO, which means we're going to reject the other one. Right? We're always deciding one or the other. So in this case, we're keeping HO because the null was, the p-value was not low. The p-value was greater. See how it's all about getting that p-value in the end? Because what is the p-value? The percent chance that the results are just luck. And it came out kind of high. It came out to be 11. There's 11% chance, right? 0.11. There's 11% chance that this evidence this guy got was just lucky. Now you might say, wait a minute, Mr. Aaron, you kidding me? The guy, the manufacturer claims that the ball bearings are weigh on average 30 grams. And the retailer thought maybe that was not true. So he grabbed a random sample of 16. And the average for that sample was 28.6. That's less than 30. So the retailer's right. It's less than 30. And now you're telling me evidence is weak, too big a chance of luck? Yeah, there is. There's an 11. The problem is that's just not many ball bearings. If he'd grabbed like 100, a sample of 100, and the average had come out lower, then we might have believed that was strong evidence and there wouldn't be much chance of luck. But if you're only getting, he only grabbed 16 ball bearings and the average 28.6 didn't come out very much lower than 30. That could have happened by random luck. He could have just happened to get 16 ball bearings that were a little bit lighter than but that really the average is really 30, right? You know, they're not all the same. Some are a little bigger, some are a little smaller. It could be the average really is 30, and this guy who grabbed the 16 at random just happened to get a lucky sample. What's the chance of that? 11%. That's what the p-value is. It's the percentage chance that it was just lucky data. Now you think, well, that's not a very good chance, 11%. Yeah, it's not the best, but it's not below 5%. They wanted us to test at the 5% level. They wanted to be sure about this, less than a 5% chance of luck. Before they take this guy to court, this manufacturer, and sue him for false advertising and not making ball bearings at the right size, they need strong evidence. They don't want a high chance of luck. In fact, so that's what they said here with the significance level. They wanted this test to be so significant that there was less than a 5% chance of luck. We didn't get that. We got an 11% chance of luck. So that's just too high. So that P is not low enough. So we're not going to reject the null. The null does not go away. We keep the null. We're going to keep this because evidence is weak. You understand? Evidence is weak. So the null, which says, we believe they're equal still. We believe the original assumption, that is that the ball bearings really do have an average equal to 30, which is what we assumed in the beginning, because evidence wasn't strong enough to prove otherwise. There was some evidence for sure, but it wasn't strong enough. There was an 11% chance it was just lucky. So which one of these is our conclusion then? Let's go through it. There is not sufficient evidence. Is that right? Is there not sufficient?
Yes.
Yeah, that's exactly right. There's not strong evidence. There's weak. Exactly. Let's read on. There's not sufficient. Looks good. So therefore, we conclude that the true mean is not less than 30. Is that what we conclude? Not less than 30? We conclude this.
It is less than 30, right?
This
Or
is
no,
what we conclude right here. We keep this. What does this say? Equals 30, right? You guys with me? We keep this. And what does this say? Equals 30. If you're equal 30, then you're not less than 30, right? So that was the right answer. Yes, not less than 30, right? We rejected, right here, we rejected the less than 30 option. We said no, not less than 30. We said equal to 30, didn't we? So that's right. Let's look at the other options and see why they're not right. There is sufficient evidence? No way. Weak evidence, not sufficient. So forget those right away. Forget those. How about this one? Not sufficient. That looks good so far. Therefore, we conclude that the true mean is less than 30? No. We do not, right? We said no to the less than 30 option right there. We said no. We kept this option. We kept the equals 30 option, didn't we? Is that good? Does everybody see that? So you really have to understand the words in the end. To do well on this test, you can't just push the buttons on the calculator. That's part of it, but you have to know what these things mean. And really, that's what matters in life, doesn't it? The whole purpose of this is that when you get done with this class, if you read, and you will see them on we live in the information age. They're constantly giving us statistical data, information, hypothesis test, data and conclusions that you can read them and understand them. So that's what really matters, is all these words. Does that make sense? Do you see how I track that through? Is there any questions I can answer on that? So again, at the very end, we concluded the p-value was not low, it was greater. So the HO does not go away, meaning we keep the HO, right? And once we realize that, we keep HO, we're saying weak evidence, so it's not sufficient, and it's equal. So not less than 30. Yeah, not less than 30 is equal. So that's how we did that.